Now come to the new concept. This concept is based on the fact that when a current carrying wire is placed in a magnetic field, then the wire experiences a force. Under the action of this force, the wire gets displaced. Okay. Now watch the following experiment to realize the fact. In this experiment, I am going to show you that a current carrying wire experiences a force when placed in a magnetic field. Okay, I have connected a resistor across a power supply through conducting wires. Okay, and also placed a magnet just below a conducting wire. Okay, now observe this wire which is just above the magnet when I switch on the supply. Okay, just have a close look. Now I am going to switch on the power supply. Again, so what we see? We see that when we switch on the supply, by keeping the magnet just below the wire gets deflected. It means the magnetic field produced by the magnet exerted a force on a current carrying wire. Okay. Now, if we do the same experiment in the absence of the magnet, okay, just remove the magnet and repeat the experiment. Observe the wire when I switch on the power supply. Okay, there is no deflection in the wire. Okay, so it doesn't mean that there is no magnetic field here. There is a magnetic field known as Earth's magnetic field surrounding the wire. Okay, but this Earth's magnetic field is too weak to deflect the wire. Okay, so through the experiment we see that a current carrying wire experiences a force when placed in a magnetic field. In the experiment, we see that when a current carrying wire is placed in a magnetic field, the wire gets displaced. It means the wire experiences a force. Okay. In the diagram, we have a magnetic field running from north pole to the south pole of a magnet, and a current carrying wire placed in the magnetic field. Okay, here the angle between the magnetic field and the current carrying wire is 90 degree. Okay, now same situation, the current carrying wire experiences a force. Okay, so this is the fact that when a current carrying wire placed in a magnetic field, the wire experiences a force. Now the question is, in which direction the force will be? Okay, so the answer is the direction of force is determined by the Fleming's left hand rule. Okay, Fleming's left hand rule says that when you stretch your left hand three fingers, thumb, index finger and middle finger, in such a way that all are mutually perpendicular, like that. Okay, the thumb is perpendicular to the index finger is perpendicular to the middle finger, and middle finger is perpendicular to the thumb. Okay, so and in such a way that the index finger pointing the direction of magnetic field, the middle finger pointing the direction of current, then the thumb will give you the direction of force. Okay, so this Fleming's left hand rule is used to determine the direction of force acting on the wire carrying current and placed in a magnetic field. Okay, so here in this case the current is in this direction, so stretch your three fingers such that the middle finger is in the direction of current, magnetic field in the direction of index finger is in the direction of magnetic field, then the thumb will give you the direction of force. So here in this case the force is upwards. The force acting on the wire is upwards. Okay, so this is the direction of force, and this force is perpendicular to both magnetic field as well as current. Okay, as well as current 96, because thumb is perpendicular to both the fingers. Okay, so the force also perpendicular to magnetic field and the current. Okay, now come to the Fleming's left hand rule. Fleming's left hand rule is used to determine the direction of force. Okay, when direction of current and magnetic field are given. Okay, so when a current carrying wire is placed in a magnetic field, then the direction of current and magnetic field are given, and the direction of force acting on the wire is given by this left hand rule. Okay, to apply this rule you have to stretch your three fingers, thumb, index finger and middle finger, in such a way that all are mutually perpendicular to each other, such that the index finger pointing the direction of magnetic field, middle finger pointing the direction of current, then the thumb will give you the direction of force. Okay, here this yellow line showing the direction of thumb. Okay, and this direction will be the direction of force. One more thing is to be noted, that force, magnetic field and current are mutually perpendicular to each other. It means force is perpendicular to magnetic field as well as perpendicular to current. Okay, magnetic field and current are perpendicular to each other. Okay, note it down.